Very, very good morning, dear students. How are you? Yes? Shillong, Churachandpur, how are you? Good? Okay. I'm also good. Okay, fine. So, how was your day yesterday? Tell me. Shillong? Shillong, Churachandpur, how was your day yesterday? Yes, I'm asking something. Tell me, how was your day yesterday? How was it? How was it? You're still settling down. Okay. Okay, where is Churachandpur? Yet to join us, I guess. Or they have joined us. Yes, Churachandpur? Okay, it was good. Good in what sense? Tell me. Good in what sense? How was it? Good in what sense? Shillong? Settle down fast, please. Yes. Settled? Settled. Tell me. Have you settled? Okay, very nice. So how was your day? It was good. I got an answer from your side. It was good. So how was it good? Good in what terms? Yes, girls, settle down. Okay, fine. So, good in what sense? What was good? Did you go back home and try to solve this? Although I had asked you to do, I will be sending you assignments. I was a bit late because my classes were in the evening too. So still, I asked you to solve only 20 questions. Okay, 20 questions means 20 minutes. So did you try to solve? Did you try to take out 20 minutes out from your valuable time? Yes, Shillong? How many of you have solved it? 20 questions only. Obviously, the first 20 questions. How many of you have solved? Okay. I should ask how many of you have not solved. Okay. Keep your hands down. How many of you have not solved? How many? Yes? How many of you did not solve yesterday's assignment? Tell me. Tell me please. Okay, so all of you have solved, that means. And what about Churachandpur? Churachandpur, logged in or yet to log in? I guess we are still to join them. Okay, fine. No issue. So did you encounter any problem? Or all the first 20 questions? I'm going to discuss only 20 questions from the beginning. So was it easy or difficult? How was it? Shillong? How was it? It was easy or difficult? Okay, so let's try one by one. Let's see how many answers you have got correct and how many questions we need to discuss, because I told you last class also that whatever questions you won't be able to solve or whatever topics you will be finding new, we will be discussing that in the form of questions, and those questions would be obviously I will be giving you detailed notes about them also, and we will be discussing them in detail too. So let's start. Okay, ready? Settle down. Fine. Let's start from the first page of the power exercise. Okay, power exercise was the one which was totally new for you. This did not come in any of the exams till now. these forms of question might have come, but exact questions were not being asked. So first question, coming to the first question, take out your phones if you have them. The assignment, yes, take out the assignment. You must be having them on your phone. Okay, fine. So first question is, pacemaker is situated in the heart, in the wall of, just look on the screen for the question. You can have the question here also. Let me know if I need to zoom it. Okay. So the first question is, pacemaker is situated in heart. Where is the pacemaker situated in heart? It is situated in heart. First is in the wall of right atrium. Yes, children, what happened? What is going on, Shillong? What is going on? Tell me first. Why are people so unstable? Tell me first. What is going on there? Tell me. Why are people not settled till now? Please. Tell me. What is the problem? Is there any problem? Is there any problem, Shillong? Tell me. Is there any problem? Let me know if there is any problem. Talk to me. I'll be asking your coordinator to manage. Tell me what is going on. Yes, second last row. What's the matter? Yes, what is going on? I'm not getting. Why people are so unstable? Is there any issue? Let me know. It's very, very difficult to continue the class in this way. Why is the row in the last so unstable? Settle down, please. It's a request. Okay, then what is going on? You don't have any problem. Then what is going on? In the second last row still, see, they are so unstable. What is going on? Please settle down. Please be attentive. I can see every student from here. Okay, I can see each and every student from here. Please. Okay, fine. Settle down. Be attentive in the class. You are coming here for a reason. Isn't it? We all are meeting here for a reason, not for talking. You can talk, but after the class, in the break, that is a particular time period, you can talk. Okay, let's come back. Okay, so pacemaker is situated in the heart, in the wall of, first is in the wall. So one of you can please come on the keyboard, or what we can do is that we can just use the sign language we used yesterday. I told you to use yesterday, and we can have those answers. Otherwise, I will be comfortable. Or all of you can like show me thumbs up for 1, for 2, for 3, for 4, what we did yesterday, or 4 for this, anything. Okay, so what is the first answer? What would be your answer? Everybody? Yes, everybody. I want everybody to participate in this discussion. What is your answer? Okay. What is your answer? Tell me. Is it this? Or this? Or this? And I told you for 4 this thing for 4. Okay, fine. So, it's good. Pacemaker is situated in the heart, in the wall of right atrium. Interauricular septum, no. Interventricular septum, no. In the wall of left atrium. So, obviously, it is situated in the wall of right atrium. One of you, please be on the keyboard. I will be asking some more questions. So, what is a pacemaker actually called? Yes, the child on the keyboard, please answer the question. What is the pacemaker actually called? What is the other name for pacemaker? Yes. Yes, you can take help from your friends. Chuachandpur? Are we connected? You are also going to participate in this discussion. I can see you logged in. Please start participating in this. Very good. So it's full form, not only essay node. Full form. Full. I want full name of the SA node. Be fast. I will be discussing only 20 questions today. Be fast. Okay, why have you taken your copy there? Okay, fine. No problem. Sinoatrial node. Very good. Very nice. Very good. Both the centers. Very good. Keep it up. Next is right atrium receives blood from, first is pulmonary aorta, pulmonary veins, inferior vena cava, superior and inferior vena cava. So what do you think? Right atrium receives blood from. So what is your answer? What is your answer? This thing? Is it? Okay. Chuachandpur? Your answer please. Your answer, Chuachandpur? I'm waiting. Please be active. So right atrium receives the blood from the body, isn't it? It receives the deoxygenated blood from the body. So that deoxygenated blood comes to the right atrium via two vessels, and those vessels are superior vena cava and inferior vena cava. And these two vessels are basically bringing blood from the upper part of the any organ situated upper than the heart and any organ situated below the heart respectively. That is superior above, inferior below. So first heart sound is lub due to closure of AV valve, lub due to closure of spiral valve, dub due to closure of AV valve, dub due to closure of spiral valve. So what is it? The answer for third question? Everybody? Chuachandpur? Lost? Are we logged in? Are we connected to Chuachandpur? Answer me the second question, please. Yes. Very good. Chuachandpur? Yes, what happened? Okay. So obviously this first heart sound is produced by closure of AV valve, isn't it? The AV valve is the auriculoventricular valve, that is the tricuspid and the bicuspid valve if you take in detail. Now, next is papillary muscles. Where are they found? Where they are found? Papillary muscles are found in which of the following parts? Ventricles, auricles. So papillary muscles, I would be like giving you a nickname for it. We have studied columnae carneae. Remember? This columnae carneae is also called as papillary muscles. Can you solve it now? Columnae carneae is also called as papillary muscles. Can you solve it now? Everybody? What is your answer? Shillong? Tell me, what is it? Very good. So columnae carneae or papillary muscles, they are in the ventricle. Very good. Keep it up. Next is, what happens when the pacemakers become non-functional? So what would happen if the pacemaker is not functioning? What is the answer? First is auricles contract rhythmically, ventricles contracting rhythmically. Cardiac muscles do not undergo coordinated rhythmic movement, and auricles and ventricles, they contract in a rhythmic manner. What do you think? So pacemaker of the heart, remember pacemaker was the SA node, just now you told me. Okay. So you are telling me that third option is correct. Okay, agreed. Very good. Very nice, keep it up. Vagus nerve to the heart is cut, the heartbeat will. Okay, I need to discuss this question. Now Chuachandpur, Shillong, be attentive please. Okay, so we will be discussing a topic from the last chapter, regulation of cardiac activity. Now, This regulation of cardiac activity is because of two things. The first thing is the nervous control. Obviously, when I mean to say nervous control, I mean to say the brain part, isn't it? And the second is the chemical control. Or better we can say hormonal control. Now, the nervous control is done by a part of your brain called as medulla oblongata. This is present in your brain. Now this has two parts. One part is called as cardio accelerator and the other part is called as cardio inhibitor. So what is cardio accelerator doing? Obviously cardio accelerator is going to increase the heartbeat. And what is cardio inhibitor doing? It is going to decrease the heartbeat. Now all of us know, okay, all of us know that these things. Can you give us answer number 5? What is answer number 5? Tell me. This is third. You people only were showing me like this, isn't it? You people only told me it's third. Obviously, if the pacemaker of the heart is not working properly, what would happen? So, pacemaker is responsible for the initiation of the beating, isn't it? Initiation of the beating means what we have is we have 72 beats in a single minute. So that is basically the rate at which the SA node generates action potential. Now if somebody does not have his or her pacemaker in a proper functional manner, what is going to happen? Obviously the work would be done by the AV node. But yes, the work will not be in a coordinated manner as it used to be done by SA node. So the correct answer for this question is number C. Option number C is correct option. That is, cardiac muscles do not undergo coordinated rhythmic movements. Am I clear? Okay, very good. For all those people who have done it correct, I can see the people on the first bench having a high five. Okay, fine. So let's resume. So we are having here cardio accelerator. The cardio accelerator part is the part. Obviously, accelerator means something which is going to increase, and inhibitor means something which is going to decrease. So cardio accelerator part is going to increase the heartbeat. Inhibitor part is going to decrease the heartbeat. So you just have an idea. We have, like, since childhood we have heard a thing that your heart movement is actually involuntary, isn't it? So whenever you talk about involuntary things, the involuntary system is basically controlled by a kind of, all the involuntary movements are controlled by a part of nervous system called as ANS. What we call is to be autonomic nervous system. Okay, so autonomic nervous system is the part which actually controls the activities which are not directly under our will. So digestion, excretion, circulation, all these things are controlled by ANS. Just have a brief idea about this. I will be discussing in detail when we will be in the chapter nervous control and coordination. Just have a brief idea. So obviously this ANS is going to control the functioning of your heart also, just like any involuntary organ. So this ANS is basically going to control the functioning of the cardio accelerator and cardio inhibitor part by two of its main branches. What are they? The first is the part called as sympathetic nervous system. Other is the part which is called as parasympathetic nervous system. Now, in the hormonal control, we have again two components. What are they? They are a bit of like lack of space. Let me know if the things are not clear. Adrenaline and noradrenaline. So what is adrenaline doing? It is again increasing the heartbeat. Okay, it increases the heartbeat. And noradrenaline, it decreases the heartbeat. Okay, so in a way I can say that this system is acting in coordination with this thing. And this system is acting in coordination with this thing. Yes, we can say this thing, isn't it? That adrenaline is actually helping the parasympathetic part. Sorry, adrenaline is actually helping the sympathetic part, and noradrenaline is actually helping the parasympathetic part to do their respective functions. Am I clear up to here? Let me know if I'm not. These things are clear? Now, to understand the functioning of the sympathetic part, you need to understand one thing. You need to have a small example. What if a dog is after you? Tell me, you are going home and you encounter a dog just near your home in a very, very ferocious manner, looking at you, barking at you. What would happen? Tell me. You will run? You will fight? What? What? You will fight? Yes, you are going to fight. Tell me, Churachandpur. Shillong, what are you going to do? You are going to fight the dog. Okay, let's replace dog with a lion. The story will be more interesting. Tell me, you are going back home and you are just about to enter in your street, and what you see, there is a big lion on the way. So what would happen? Tell me, Shillong, tell me, Churachandpur, what is going to happen? You are going to fight? Or you are going to flight? You are going to run away? Tell me, Dharmender can fight. He is a Bollywood hero. I don't know, you people must have heard about him. Dharmender, he actually had a fight with real lion. Okay, run, obviously. Churachandpur is going to run. Okay, fine. Shillong, what are you going to do? Okay, run away. Okay, be on the keyboard. Shillong, Churachandpur, I'm going to ask more questions. Be on the keyboard. You are going to have more questions regarding it. Now, imagine one more thing. What is going to be the actual rate of your heartbeat? Is it going to be fast or slow? After seeing lion, your heartbeat is going to increase or decrease? Tell me. Fast. Churachandpur? Shillong is telling it is going to be fast. Yes, increase, exactly, obviously. And what about your other body activities? Obviously, your blood supply to the limbs are going to increase. Agreed? Isn't it? The blood supply to your limbs is because you are going to fight or flight. Either you will be fighting the lion or you are going to run away from it. So, you are in actually a situation which I feel you need sympathy. Okay, so you are in a situation where we have a sympathetic condition that needs an increased heartbeat. Okay, that needs an increased heartbeat, and that's courtesy the sympathetic nervous system and one more member, that is adrenaline. Isn't it? So, sympathetic nervous system and adrenaline together, what they do is that they make you comfortable in a situation where you need sympathy. You can need sympathy anytime. You need sympathy when you fall down, when you are running, you fall down, you are in front of a lion, you have your exams, okay, all those things. So, this is what is the part of the nervous system going to increase your heartbeat, that is, it is going to actually have a greater supply of blood. Now, next thing, when I'm talking about parasympathetic, the parasympathetic nervous system works in coordination with noradrenaline. Obviously, noradrenaline, the reverse effect of adrenaline is called as noradrenaline. It's going to bring about exactly reverse effects. Reverse effects in what terms? It is going to decrease the heartbeat. Okay, when I'm sleeping, my body is actually relaxing and I am having a minimum of functioning, and this is done by vagus nerve. The exact name of the nerve which does this relaxation activity for me is called as vagus nerve. So this is a good question. Okay, what is it? It is the vagus nerve. And what is vagus nerve doing? Vagus nerve is actually helping you understand how to decrease your heartbeat when not needed. Obviously, sympathetic nervous system is going to consume a lot of amount of energy, isn't it? Because whenever you are in sympathy, your heartbeat increases, your blood pressure increases. So every reaction of your body is in a hyper manner. So I need a lot of energy to combat that system. I need a lot of food, blood supply, all those things. But when you are sleeping, when you don't need to work very hard, you are just relaxing, your cardio-inhibitory part, what does it do? In coordination with the vagus nerve, it actually decreases the heartbeat. Obviously, this the same effect is brought about by the other thing, which is basically called as what? Which is basically called as the same effects. That is the noradrenaline part. Am I clear? Everybody, am I clear? Now come back to the main question. This concept is clear to everybody? So which is the part of the brain controlling these activities? The part of the brain controlling these activities is the ANS part. This is the autonomic nervous system which is going to control these things. So am I clear about all these things? Tell me. Is the concept clear? Tell me. Yes or no? Everybody. So sympathy is required when you are under a situation where you demand a high amount of energy, and vagus nerve is doing the reverse effect, that is, it is going to decrease the heartbeat. Now, let's come back to the question. What was the question? The question number 6, isn't it? The question was, if vagus nerve to the heart is cut and heartbeat will. So what is going to happen? Just see the notes. Just know what you have written. Now cut the vagus nerve. Just put a cross along the vagus nerve, imagining that the vagus nerve of the person has been cut. Now what is going to happen? Heartbeat is going to decrease, increase, remain normal or stop. Heartbeat is going to decrease. Okay. Just analyze it once more. Chuachandpur, Shillong, analyze it once more. What you are going to do? You are going to actually cut the vagus nerve. Just try and cut the vagus nerve. Try to cut the vagus nerve. So if you are cutting, let's see. Let's see. Okay, come back. See here. What I am doing is, I am just cutting the vagus nerve to make your understanding better. What I did is, vagus nerve is cut means this whole thing is going to get wiped up. Isn't it? This whole thing is going to get wiped up. Means what is left? The inhibitor part is not going to act. Means what is left? I will be left with increased heartbeat. Am I clear? If the vagus nerve is cut, there will be no one to check its acceleration. So what is going to happen? The heartbeat will have an accelerated effect. Just imagine vagus nerve is a police which checks on the speed of the vehicles. Okay. So if police is not there, what is going to happen? People will do rash driving, isn't it? Am I clear? Let me know if I am not. Yes, everybody Shillong? Is it clear? Bice? Okay, yes. I get it. B, yes. Okay, fine. This question often comes in exam. Okay, very good. This question is often asked in exam. This is a very, very good question. So whenever vagus nerve is cut, keep in mind the heart rate will always increase, because vagus nerve is the police which checks the speed of the vehicles going through a particular road, going on a particular road. See, if police is not there, what people are going to do? They are going to do rash driving. Now, next is 7th question. If T wave of ECG, what does it represent? Churachandpur, Shillong, what's the answer? Ventricular depolarization, ventricular repolarization, depolarization of auricles, or auricular repolarization. See, this particular thing, when you talk about depolarization, depolarization means relaxation. Contraction. Depolarization means contraction. Repolarization means relaxation. Since we did not do action potential till now, so when we are supposed to do that thing, this will be more clear. So depolarization means contraction and repolarization means relaxation. Now can you answer this question? T wave represents what? Ventricular contraction or ventricular relaxation? What is it? Churachandpur? Very good. Both of you. Both the centers. So obviously this question is, question number 7 has correct option as B. Let's move ahead. Hardening of wall of small arteries is known as thrombosis, arteriosclerosis, atherosclerosis, myocardial infarction. What is it called? Small arteries are getting hardened. Hardening of wall of small arteries, what is it called? Hardening of wall of small arteries, what is it called? A small hint, I have not discussed this question with you. Still try. I have not discussed this thing with you. Try. What it should be? Yes. Shillong, Churachandpur, what do you think? First. Second. Third. What? Second. Arteriosclerosis. Okay, I did not teach you this. How come? Very good. Very nice. So, one thing we have to keep in mind, we have two different kinds of things. See, we have atherosclerosis and we have arteriosclerosis. Atherosclerosis is when the walls or when the lumen of the coronary artery is affected. And this is any other small artery but coronary artery. So when you are not involving coronary artery but any other artery, what we call it to be? We call it to be arteriosclerosis. Am I clear? Everybody? Okay. There's one more thing given in the question. It is thrombosis. Isn't it? The full form of thrombosis is actually coronary thrombosis. What is coronary thrombosis? A small clot is formed in coronary vessel. Okay, do you know this thing? Have you come across this? Do you know this? What is this? Have you studied streptokinase? Remember streptokinase? Shillong? Chuachandpur? Do you remember streptokinase? Sounds familiar, isn't it? Sounds familiar. Where did you see it last? Tell me. Okay, one more thing. One more. Sounds familiar? Yes or no? Have you heard about this thing? Streptokinase, have you heard about clot busters? In a chapter, Microbes in Human Welfare. Have you read about clot buster? You must have. This streptokinase is used as a medicine which actually is used as a clot buster. Chuachandpur Shillong. It is used as a clot buster to dissolve this clot. So what it does is dissolves the clot. So this is what we call is thrombosis. Coronary thrombosis, a small clot is formed in the coronary vessel, and this clot is basically important, and this can be dissolved using a simple enzyme called as streptokinase or statins, which are used as clot buster to dissolve the particular clot. Done? Okay. Can I call this atherosclerosis to be coronary artery disease? Can I call this? See here, everybody. Can I call this coronary artery disease, or in very short CAD? Can I? Can I call this coronary artery disease or CAD? Atherosclerosis. Yes, I can say. So they are also called as coronary artery disease or CAD. Fine? Copied everything? Come back to the question paper. We had to discuss. Chuachandpur, copied? Okay, fine. Come back. So this was the, okay, what is myocardial infarction? What is this? What is myocardial infarction? Tell me. What do you understand by myocardial infarction? What is myocardial infarction? You know this term. You know heart attack, no? You know heart attack? Myocardial infarction is a better word what doctors actually use for heart attack. Okay? So myocardial infarction is similar to heart attack. Fine? Shall I move ahead? Okay. So heart murmur is due to, when will your heart start to murmur? Murmur means to produce a hissing sound. Shh, shh. This kind of sound. So when is the heart murmuring? Coronary thrombosis, defective leaky valve, arterial pulse, ill-developed atrium. When do you think this heart murmur is going to happen? What do you think? Yes, Chuachandpur? Shillong? You have done this as an assignment. Tell me. You must be ready with your answer. 20 questions I asked. 20 question means 20 minutes, hardly. Okay, so what are you trying to show me? Thumbs down. Chuachandpur, what is your answer? So obviously, when the tricuspid and bicuspid valves, they are not closing properly. Okay, when tricuspid and bicuspid valves are not closing properly, what is going to happen? There is still some leakage of the blood when the walls close. So ventricles, when they start to contract with full force, there is some blood leaking back into the auricles, and that particular blood leaking back, moving back in the auricles produces a hissing sound, which is often termed as murmuring of the heart. Fine? Next, 10th question. Heart pumps blood more forcefully in older person than younger ones. Why? Due to decrease in oxygen content, decrease in elasticity of the arteries, fall in nutrient content of the blood, increase in elasticity of the arteries. Yes, what do you think the correct answer should be? Why is the heart pumping more forcefully in older people than in younger people? What do you think? Yes, Chuachampur? What should be the answer, correct answer? According to you, what is the correct answer? What do you think? Yes, Shillong? Tell me. Nice question. Tell me, it's a good question. Tell me why is, in fact, it is a practical implication of whatever you have studied. This is a practical application of all those things. So heart pumps blood more forcefully in older people. Why? Decreased oxygen content of the blood. Decreased elasticity of the arteries. Fall in nutrient content of the blood. Why? Why nutrient content? Why it is going to fall? No. Increase in elasticity of the arteries. In no case the artery elasticity is going to increase in older people. Why? Because anything which is, see, what happens actually is, when our tissues, they wear out, when our very, very important tissues, they wear out, they are randomly replaced by any other tissue. It might be a chance that they are replaced by the same tissue. That is what is called as emphysema also. If you remember, in cigarette smokers, the disease called as emphysema is very, very rampant. That is basically because when the alveoli, which was actually elastic in nature, it was damaged because of cigarette smoke, it was not replaced by the same kind of material, but it was replaced by a different kind of fibrous tissue. Isn't it? That is what is emphysema is about. So this gives you a correct option that this is obviously no, this is no, this is also not correct. So what we have is basically the elasticity of the arteries, they start to decrease. Okay, the elasticity of the arteries, they start to decrease, and because of that, what happens is the heart starts to pump blood more forcefully. Isn't it? It starts to pump. Okay, Chuachandpur, is it clear? Okay, next. Doctors use stethoscope to hear the sounds produced during each cardiac cycle. The second heart sound is heard when? Tell me, it's very easy. See, this was there in AIPMT also. Tell me. Can you see this clearly? Yes. Tell me. This was asked in AIPMT 2015. See, a very good question. These kinds of questions do come in NEET, AIPMT. AIPMT was earlier called as, NEET was earlier called as AIPMT. Tell me. Okay, fine. Have you done? Chuachandpur, Shillong, have you done this question? Yes, what is the answer? Doctors use stethoscope to hear the sounds produced when each cardiac cycle, okay? So first heart sound is lub, just now we did a question. The second heart sound is dub. When is the second heart sound produced? AV node receives a signal from the SA node. AV valve opens up, no. Then we have is ventricular walls vibrate due to gushing in of blood from the atria, so what? If it is vibrating, it should not produce a sound. If it is receiving a signal, in that case, it could not produce a sound. It can only produce a sound when, what? Exactly, very good. When the semilunar walls close, the typical heart sound produced is, what is it? Isn't it? Very good. Keep it up. Both the centers. Next question. What is the strokes volume of an adult human heart? A very good question. Very, very easy question. This came in West Bengal 2015. What was it? Very good. Very nice. Chuachandpur, what do you think? Should be the correct option. Please be fast. Very good. So, we have 70 ml as the strokes volume. And how much is cardiac output? Both the centers. How much is cardiac output? How much is cardiac output? It's very easy. 70 multiplied by number of times your heart is beating in a single minute is called as cardiac output. So it's 70 into 72, giving you 5040 ml. That is equivalent to 5 liter. So your cardiac output is 5 liter in a single minute. Okay? Next is identify the correct statement regarding cardiac activity. The first is normal activities of the heart. If you have done, you can type the option as well. If you have done. If you have solved this question, keep on typing the options. We can save some time. So, cardiac normal activity of the human heart is regulated intrinsically, hence it is neurogenic. No, our heart is never neurogenic. We cannot call our heart neurogenic. Our heart is myogenic. So, this single word removes this option. A special neural center in the medulla oblongata can moderate the cardiac function through CNS. Okay? Parasympathetic neural signals increase the rate of the heartbeat. No, just now we did this thing and now we know that the sympathetic neural signals actually increase the heartbeat and parasympathetic ones, they decrease the heartbeat. Next, the adrenal medullary hormones can increase the cardiac output. Okay, this seems to be what? Adrenal medullary hormone can increase the cardiac output. Let's just have a pause on this option. Next is end of a T wave. End of a T wave marks the end of the diastole. So what do you think? What do you think should be the correct answer? Tell me, what is it? Why not this? The end of the T wave marks the end of the marks the end of the ventricular diastole. Why not this thing? Tell me why this? Tell me. See, what we can interpret from this is a good question. See, what we can interpret from this question, this was easily ruled out. Now, see, a special neural center in the medulla oblongata can moderate the cardiac function through CNS. This is wrong. Why? Because this should have been ANS. Because medulla oblongata itself is a part of CNS. It cannot control the events with the help of CNS, but it is going to control the events with the help of ANS. Now, next, we have adrenal medullary hormones which can increase the cardiac output. So, what was cardiac output? Number of times the heart is beating, that is 72 multiplied by 70. So, if the heartbeat increases, if I am increasing 72, the cardiac output is also going to increase. If I am decreasing 72, the cardiac output is also going to decrease. So, this option seems to be correct. I guess we have two options correct, either this question has two correct options, D and E both. So, if you are going for either of them, they will be giving you full marks. So, this is adrenal medullary hormone, that is what we call as the adrenaline and the noradrenaline. But one thing what actually makes unclear, why they have mentioned hormones. Why are they mentioning hormones over here? It should be hormone. If it was only hormone, this would have been a very, very perfect answer. So, this is a tricky question. This would be the first option correct, and this would be the second option correct. If this option is not present, then only we have to go for this option. Because there is one hormone only. Come back to this thing. See, there is only one hormone which is going to increase the heartbeat. See, this is a hormone which is going to, this chemical control hormone, and we are very, very correct. This is coming from the adrenal medulla part. We know this thing. So, adrenaline and noradrenaline. So, they are mentioning, the thing is mentioned over here is hormones. If this option was not there, the only option you people had to select correct, it was no doubt D. But this S thing, hormones, makes this option to be the next priority after this completely correct option. That is, the T wave marks the end of a diastole. This is completely correct. For this question, I will be always advising you people to go with the E option. Clear? This was a good question. Clear? So, very, very specifically, I would like to add that be very specific with the words. Because what happens, there are small words. See, hormones, hormone. It is a small word, only S. But the whole theory is being changed because of only one S. So, if it would have been hormone, this option would have been also totally correct. But now what we have is, we have a better option than that, and then we will be going for this option. So, very, very analytically you have to answer these kinds of questions. Okay, these kinds of questions, they need to be answered very, very, because that leads to -1 marks immediately if you are having an incorrect option. Okay, it's clear, Chulachandpur, Shillong? It's clear how to handle these kind of questions? Okay, very good. So, I'm moving ahead. Read the statement A and B and select the correct option. The first statement what given is, atherosclerosis is a disease characterized by thickening of atrial walls. Next is deposition of cholesterol and triglycerides in the atrial wall causes atherosclerosis. So, what causes atherosclerosis? What have we done? Okay. So, this statement is in some way, that statement A is correct, B is wrong. No. I find that both these statements are correct. This is wrong. What do you think? What should be the answer? Yes, Shillong, Chulachandpur? What do you think? Before interpreting, tell me, you have solved it, no? Tell me, what is your answer? I guess we did not discuss for this question. Very good. Very nice. Keep it up. Chulachandpur, do you agree? Do you agree that atherosclerosis is a disease characterized by thickening of the atrial walls? Yes? You must be, because we have done this in the last class yesterday. Then deposition of cholesterol and triglycerides in the atrial walls causes atherosclerosis. Yes. This was the thing which was responsible for this phenomenon. Okay. Ventricular diastole occurs due to A, organ system, cell organelle, tissue or organ. Why does the ventricular diastole takes place? Fifth question. This was asked in AIMS 2012. What do you think ventricular diastole must have taken? Due to organ system, cell organelle, tissue or organ? Chulachandpur, Shillong? Organ system. And which organ system? See, this is a very good question again. Organ system, what do you mean by organ system? Organ system means, like, if you're talking about heart, heart is also an organ. Heart is not an organ system. Organ system means we can talk about the whole digestive system starting from mouth to anus is a organ system. You're involving each and every part of the system of the particular process that is said to be an organ system. So ventricular diastole has nothing to do with the organ system. No. Cell organelle? No. Organ? No, because in the meantime, the auricles are actually already relaxing. So obviously heart is having a different phase in each of its components. Why? Because each of the component is made up of a different tissue. So the correct option would be C. Very good. Churachandpur, are you getting the things? The frequency of heartbeat in our body is maintained by. Now answer this. This is very easy. An easy one. Tell me. The frequency of heartbeat in our body is maintained by AV, SA, node of Ranvier, chordae tendineae. What is it? Be fast, please. CB? It can be either C or B, not CB. Churachandpur, what do you think? The frequency of heartbeat in our body is maintained by Churachandpur. Okay, Shillong, got your answer. Churachandpur, are you people there? Please answer this question. This is an easy one. You have not solved the assignment. Have you? Churachandpur, tell me, did you solve the assignment I gave you yesterday? Tell me. Did you solve the assignment I gave you yesterday? Tell me yes or no. Yes, Churachandpur. Are we connected? Tell me. Did you solve the assignment I gave you yesterday? It was late, I know, but still you can take out 20 minutes from your busy schedule. Yes, Churachandpur, please reply. I'm waiting. No response. What happened? So obviously the frequency of the heartbeat is always and always maintained by sino-auricular node. Again, easy question. Medulla is a part of which of the following organs in human? What is this question? So obviously now we have like only questions from body fluids and circulation. That makes it very, very clear that this must be always and always heart. Exactly. Then given below is the ECG of a normal human. Which of the following component is interpreted correctly below? So complex QRS. Okay, QRS complex is one complete pulse. Peak T initiation of the total cardiac contraction. So peak T, this means this thing. This initiates the total cardiac contraction. No, this represents the diastole phase. Isn't it? What is your answer? This is question number 8. What is your answer? Tell me. What is your answer? Next is peak P and R. That is peak P and R. Together they are representing systolic and diastolic blood pressure. Is it? This represents a systole. This also represents a systole. So this again is incorrect. Peak P initiation, that is this particular point, initiation of the peak P of the left atrial contraction only. But peak P is actually initiation, is not the contraction part. In fact, the peak is contraction. This would have been peak. This would have been a correct option. Because initiation is just the phase when the heart is beginning to show contraction, but it has no complete contraction. So this makes the first option to be completely correct. Very good. I can see your answer. Cardiac muscle, Churachandpur, where are you lost? Are we logged in? Where did you go? I guess we have lost connection. Cardiac muscle is found in Obviously, what of this? Which of these has cardiac muscle? Tell me. Which of these has cardiac muscle? Yes, Shillong? What is it? 1, 2, 3, 4. What is it? All of these. Okay. What if I say ki no, not all of these? What if I say that cardiac muscle is found in not all of these? Yes. They are the covering of the cardiac muscle. They are connective tissues. Yes, they are connective tissues, and they don't have any cardiac muscle. They are simply connective tissue. Any simple connective tissue that forms the covering of your important organs. So epicardium, endocardium, they are actually the cover of your heart. So cardiac muscle is only and only found in myocardium. Fine. Last question for today. Which of the following is the correct pathway for propagation of cardiac impulse? What do you think? What was your answer? Tell me. Show me your sign. What is it? Chua-Chandpur? Please answer this question. Tell me. What is it? Everybody. Answer this question, please. All of you. I want each and everybody to answer. I'm not looking at the computer screen now. Tell me. I'm looking at the camera only. Tell me. What is it? Yeah, exactly. Very good. So this is the correct, very easy question. See, this is the correct pathway, SA node to AV node to bundle of his and Purkinje fibers. So this was a good practice in fact. So I'm leaving the rest of the questions that are to be done today. Okay, we'll be discussing these questions in the next class. And what I will be doing is that we will be starting discussing questions from digestion from the next class. Okay, so today I'm giving you more time to solve these questions. And if you wish, you can solve many more questions from all the MCQs you are having, MCQ books you are having. So in the meantime, what I will be doing is that I will be resuming my chapter that I was discussing yesterday. What was it? It was digestion and absorption. So let's resume the class. Let's have the chapter digestion and absorption. So how was the discussion? How were the questions? How were the questions? Did you find them to be good? Some of these questions were from the exams. That's why I gave you selectively those questions also, so that you can have some confidence. So how do you find this chapter to be now? Can be sorted? Easy one or difficult? Easy. Yes, Shillong, Chua-Chandpur? Easy one, difficult? What kind of chapter is it? I'm sorry, I'm always making somebody to get up and write. Really sorry. Okay, thank you so much. Average. Okay. Okay, 1 question to 10 average. Okay, fine, average. Okay, glad to know that. Average. So digestion must be easy then. If body fluids was average, digestion must be easy. Okay. So yesterday we were discussing the types of teeth in your mouth, and we actually discussed many things about your teeth, and I was supposed to tell you today what is the hardest known substance in your human body. You answered me in fact that yesterday only, that happens to be the enamel. So you told me that enamel is the hardest known substance in the human body, isn't it? Now, more to add it, this is the only visible white part of your teeth. This is a visible white part of your teeth, and it is called as what? It is called as enamel. Now just below enamel you have the second part of your teeth called as dentine. What is dentine? Dentine is the part of teeth below enamel. So dentine happens to be the part of teeth present below enamel. Clear? So we have two parts of the teeth, the visible white part that is called as enamel, and just below the enamel what we have is, we have the dentine part. Clear? Okay. Now dentine can be of two types. I'm a bit elaborating things. This dentine is actually secreted by a special category of cells called as odontoblast cells. Okay. And based on the activity of the odontoblast cells, the dentine can be, or the particular thing can be open-rooted, or it can be close-rooted. Open-rooted as found in rodents. That is, teeth keeps on growing throughout the life. So this is called as what? This is called as open-rooted teeth. Okay, you must have seen the rats. They keep on, actually what we know is that rats, they actually destroy many things, isn't it? We always have seen rats destroying books, destroying grains, destroying many important things, clothes and all those things. But actually what happens is their teeth has open roots, that means they keep on growing. So if they don't chisel it, if they don't have a particular phenomenon where they are actually rubbing of their teeth, they are actually decreasing the length of their teeth, they will be leading to, the teeth will keep on growing, and a particular point of time will come when they are actually unable to eat anything. So to avoid that particular process, what they do is that they keep on chiseling their teeth in a way that their teeth has always an average length that does not hamper with the growth of their, or hamper with their food eating habits. Am I clear? So that is why they keep on cutting your things, keep on destroying things. And closed-rooted teeth, obviously the teeth does not grow throughout the life. Obviously the opposite of it. Example, is obviously we humans. Who else than we humans? So we have examples like rodents. We have examples like humans. So these are the particular types of teeth. These are the particular cases where we have actually what? We have open-rooted and closed-rooted teeth. Clear? Churachandpur, Shillong, are we clear? Okay, fine. So this was all about your teeth. Let's come to the tongue part. Copy it. Shillong, Churachandpur, yeah, okay, fine, very good. Let's come to tongue part. So what about tongue? Tongue is obviously an organ which allows you to first mix the food. It allows you to taste the food as well. And it allows you to speak also. So language formation, word formation is actually courtesy tongue only. So what is happening over here? We are actually having the whole thing. First of all, the whole thing, the whole oral cavity. When you talk about whole of the oral cavity, it is lined by, the whole of the oral cavity is lined by stratified squamous epithelium. These kinds of things. Okay, so what is stratified squamous epithelium? Anybody? See, there are three kinds of epithelial tissues. The first is squamous, second is cuboidal, third is columnar. You must be coming, we will be discussing this thing in detail in chapter number 7, class 11, that is animal tissues. So, stratified squamous epithelium. Now, stratified means layered. That is, layered means one over the other. So, we have actually two different kinds of epithelium. One is simple and one is compound. Simple means having a single layer. So, that squamous epithelium will be having only one layer. Okay. Cuboidal epithelium will be having only one layer. Columnar epithelium will be having one layer. So, this kind of epithelium is called as simple squamous epithelium, simple columnar epithelium, simple cuboidal epithelium. Now, the next category is when we have layers of squamous epithelium, one over the other, or we have layers of columnar epithelium, one over the other, and same with cuboidal epithelium. So, we will be calling it to be stratified. Stratified means layering, stratification, one over the other. What kind of epithelium? Squamous epithelium. So, this is layering of the squamous epithelium which forms the oral cavity. So, stratified means layering. There are many layers. So, layerings of the squamous epithelium is present in many layers to compose your oral cavity. Am I clear? Now, moving to the next thing, what we have is the tongue. Have you heard about palate? How many of you have heard about palate? Tell me what is palate, Churachandpur, Shillong? What is palate? What is palate? Okay. Just use your tongue. Okay, use your tongue to touch the roof of your mouth. Okay. You must be having two parts. One which is present in the anterior end and the other which is present in the posterior end. This kind of structure that you must have seen in animations. The end part. So palate is actually what? Palate is actually the roof of the mouth. And it is having two different parts, the anterior and the posterior. The anterior palate is obviously this particular thing. This helps you in speech. And the posterior thing is called as uvula. This particular thing, which keeps on hanging at the end of your mouth. Have you seen that? At the end of the buccal cavity, there is a particular thing which is hanging down. In animations, you must have seen, in cartoons, you must have seen. This is called as, so both uvula, both these things, that is palate and tongue, they are actually covered by keratin. What is keratin? Keratin is a dead protein layer. What is keratin? Keratin is a dead protein layer. Okay. This anterior part is actually hard and the uvula part is not too hard, it's comparatively softer. Am I clear? So what is the covering of the palate and tongue? The covering of the palate and tongue is by a surface of, by a layer of dead protein called as keratin. So keratin is present. This keratin is present in your hair also. Similar kind of structures, but the composition is varying. The structure is varying. Okay, fine. Can we move ahead? Tell me yes. Chuachandpur, Shillong, can we move ahead? Yes. Shillong, Chuachandpur, clear? Are the things clear up to here? Tell me. Okay, very good. Chuachandpur, everything clear? So what is the hanging part of the palate called as? The hanging part of the palate is called as uvula, which is the posterior part of your palate. Now, let's discuss about the tongue, the different kinds of things we are having in tongue. So tongue is actually having many papillae. What is papillae? We can say papillae, we can compare papillae to pits, pit-like structures. So tongue has actually 4 different kinds of papillae. Let's start seeing one by one all of them. The first is valate, the second is fungiform, the third is foliate, and the fifth is filiform. Now, the valate happens to be the largest of the papillae, but only 8 to 12 in number. The fungiform has high number near the tip of the tongue. And then we have foliate. This is not present in humans. Actually, they were present when we are born, but gradually they degenerate. It is said that this is present in dogs. So a kind of thing which actually we see in evolution, that if we don't need anything, that degenerates. Okay, so this is not present in humans, absent in humans in fact. Next is what we have is filiform. This filiform is the smallest plus highest in number. Okay, but surprisingly, what we know about filiform is that they do not have taste buds. What they do have then? They have tactile receptors. Now, what is tactile receptor? Tactile receptor is a particular kind of receptor which tells you about the sense of touch. It gives you a sense of touch. So, this is called as tactile receptor. So, filiform apparatus, although filiform papillae, although highest in number and smallest in size, they are not of use to taste substances. Why? Because they do not have taste buds. But what do they have then? They have a special kind of receptor which is called as touch receptor or tactile receptor. This gives you a sensation of touch. Okay? Are we clear up to this? Tell me. So we have 4 different kinds of papillae. You need to learn all these things. Okay? You have to learn all these things. This is the different forms of taste buds you have. Okay, so what does tongue have? Tongue has papillae. Fine? So moving ahead, what we are now heading towards, from the buccal cavity, the food enters into the common opening which is called as pharynx. Let me know if you have not copied. I guess you must have copied everything. The food enters into pharynx from the buccal cavity. Yes, Churchandpur, Shillong, you copied, isn't it? You did not miss out anything. So what is pharynx? Pharynx is a common opening for food and air. So what we are going to do is that we are going to divide the pharynx into 3 different parts. The first and foremost, the uppermost part of the pharynx is called as nasopharynx. Then we have is oropharynx, and then we have is laryngopharynx. So these are the 3 different parts of the pharynx. Let's see. This is present behind the nasal cavity. This is a common opening for food and air. And this is common passage, laryngopharynx. This leads to esophagus. Okay. You must have heard about lymph nodes, isn't it? There is a particular ring-like structure called as Valdeir's ring. Sorry. The ring-like structure called as Valdeir's ring. And this Valdeir's ring is what? This is a lymphatic tissue. Similar to the Peyer's patches you have studied in the last chapter, last year, Human and Diseases. This is a lymphatic tissue. Where is it present? This is present in the pharynx, in the pharynx region. And this is known to produce a very, very important antibody. It's called as IgA. This Valdeir's ring, important. This is a lymphatic tissue again. And where is it present? It's present in the pharynx. So one more thing important about pharynx, now you know, is apart from its common opening for food and air, what you know, new thing about it, it has a ring-like structure, which is actually a lymphatic tissue called as Valdeir's ring, and this Valdeir's ring produces IgA, that is antibody A. Okay? Now, food from pharynx passes down to which organ next? Tell me. What is the next organ the food passes to? Yes, children? The food passes to which particular organ now? Which organ? First of all, you need to swallow the food, isn't it? The food is swallowed and reaches the esophagus part. Now, since childhood, this is the third part. Since childhood, we have studied one thing very, very important, that there is a movement called as peristalsis, which is what? Which is contraction and relaxation in a rhythmic manner. So rhythmic contraction plus relaxation is called as peristalsis, which is actually responsible for what thing? Responsible for movement of the food in the... So the process of swallowing the food, from non-words you will be having a new word also for that. It's called as deglutition. So what is deglutition? Deglutition is the process of swallowing the food, and this process we all know is a reflex action. This need not be always be in mind what we have to do with this thing, but this is a particular process which is in reflex action. Okay? Am I clear? This is what we call as swallowing action. So tell me now one thing, is esophagus a voluntary or involuntary organ? Is it voluntary? The whole esophagus I'm talking about, or is it involuntary? Tell me, is it voluntary or involuntary? For voluntary, you can have one thumbs up and thumbs down. For involuntary, Chua Chanpo, you need to type. We don't have any option. Tell me, is it voluntary or involuntary? Thumbs up for voluntary, thumbs down for involuntary. Or both? Or both voluntary and involuntary? Tell me. Both voluntary or involuntary? Chua Chanpo, what do you think? Okay. Voluntary. Oh, why voluntary? And why involuntary? Why voluntary and why involuntary? You try to swallow your food without the, it is reflex, no doubt, but if you don't try to swallow your food, you can just make your food to, you can just take out the food also. If you, at the end point, you can just try to reverse it also. You need not always swallow it. So what we think is, the esophagus is actually, if I'm talking about this part, whole of the part I'm drawing, esophagus is actually, if divided into three parts. So this is the whole tube divided into three parts. So 1/3, 1/3, 1/3. The upper 1/3 part of the esophagus is voluntary, and the lower 2/3 parts, are involuntary in action. There's something new, so I'm replacing it, the slash, with a plus sign. So what we now know about esophagus is actually a tube-like structure which has, if divided into three parts, it has the upper 1/3 part to be voluntary and lower 2/3 parts to be involuntary. Clear? Okay, let's move ahead. Now the food from the esophagus is passed on to a J-shaped bag. The J-shaped bag is called as stomach. The J-shaped bag. This particular structure is called as gastric rugae. The stomach is divided into three parts. The starting part or the first part is the cardiac. The roof is the fundus. Roof of any organ is said to be fundus. In uterus also you must have studied fundus of the uterus. This is body, and the end part is called as pyloric. Now this pink thing is actually a sphincter. Sphincter is a particular kind of you can say a kind of covering or a kind of aperture which actually closes when the food enters from the esophagus into the stomach. So just to prevent the backflow of the food from the stomach into the esophagus, what we have is, we have a kind of sphincter, and that sphincter is called as cardiac sphincter. So what sphincter does? Sphincter actually prevents the backflow of the food. Now similarly, we have one more sphincter here also. This is called as pyloric sphincter. The same function, that is, once the food enters the duodenum part, this is the duodenum, it should not go back. Now, gastric rugae, the function of gastric rugae is to allow distension of the stomach. So when you have, okay, so what do you like? What's your favorite food? What is your favorite food? What is your favorite food? What do you think? What is your favorite food? Yes, Churachandpur, Shillong. What is the most favorite food that most of the children like at your place? Yes. Tell me, and what is the most non-popular food among you that you don't like? What is it? Tell me, somebody has to type it. Okay, the girl on the first bench, white top. Okay, you are ready to type? Okay, type. Please. Type. Yes, Churachandpur. What's the favorite food you like? Nothing. Oh my God, you like rice and dal? Okay. Everybody in your batch likes rice and dal. Everybody. Oh wow. Is it correct? I'm dreaming. Are you serious? Tell me. Yes, Churachandpur. Are you serious? Very, very good children. You people like rice and dal. That is your favorite food, rice and dal, isn't it? So, you don't like pizza and burger and all those things? Shillong? You don't like fast food? Pizza, burger? No? Give me a thumbs up, thumbs down. You don't like that? Yes, Shillong. No pizza, burger. Are you able to hear me? Tell me. Yes. You're on break. Okay. Okay, fine. So just I was trying to explain you something using your favorite food. That was the main motto. See, I wanted to explain, like, see, suppose I like a dish very much, or I like a very, I like a thing very much, or I need to have a huge amount of water. What happens is, this gastric rugae, this undergoes distension. Distension means the whole thing is like, what you are seeing over here in the diagram. This is actually arranged in this manner, isn't it? This is arranged in a spiral manner over here. So this whole thing gets straightened up if you are having extra water, or you are having some food that is of more interest to you people. That is why I was asking you what was your favorite food. Okay, and if you don't, the gastric rugae remains contracted. That means if you are eating less, if you are eating normal, the gastric rugae will resume its normal shape. And if we are having extra amount of water or extra amount of food, obviously, what is your favorite would be always extra, I guess. So whatever is your extra thing that can be accommodated in the stomach when the gastric rugae starts to distend, that is, it starts to open up. Okay, fine. So this was your stomach. Just let me finish this intestine part. I will be giving you a break. I know you need break. Okay, just let me finish this. It's a small part. So from stomach, the food enters into the next part, that is the small intestine. The small intestine is the longest part of your alimentary canal. This is like somewhat 6 to 8 meters long tube-like structure. The first part happens to be duodenum. Then we have is jejunum and ileum. This is the first thing. So what is duodenum? Duodenum is the part where three things are going to open. First, the stomach opens. Then there is a duct called as hepato-pancreatic duct going to open. This duodenum has many cells that produce digestive enzymes. Okay, this is jejunum. Jejunum is the next part followed by duodenum. And what is jejunum doing? Jejunum is very, very actively involved in absorption of food through finger-like structures called villi. Okay. Next we come to ileum. What is ileum? Ileum is basically the last part, and this happens to be the longest part also of the small intestine. And this particular part leads to the large intestine part. Okay, one more thing you have heard about small intestine. It has Peyer's patches. You have done this also in the last class. In 12th class. It has Peyer's patches, and these Peyer's patches, they produce lymphocytes. You know now what are lymphocytes. They are the warriors, they are the soldiers of your body, the B cells and the T cells. Fine? Okay, let's move ahead to large intestine now. The large intestine is again divided into 3 parts. The first part of the large intestine is called as cecum. Then we have is colon, and then finally we have is rectum. Cecum is a blind sac-like structure. What is cecum? Cecum is a blind sac-like structure. Colon next to cecum, this again is divided into 4 parts. The first is the ascending colon. Then we have is transverse colon, followed by descending colon, and last we have is sigmoid colon. So what happens in all these systems? The food actually, there is reabsorption of water from the food. And finally we have rectum. Rectum is the part where there is temporary storage of the fecal matter. I don't have enough space to write, so I'm writing over here. And finally the rectum part leads to the end part of the large intestine or the end part of the alimentary canal into anus. Excuse me. So this is the whole. One more thing, we have a small vestigial organ over here. It's called as appendix. It's a vestigial organ in human. Done? Okay, so let's have a break, small break. We'll be resuming the class in next 10 minutes. 55. Okay. Okay, come back after break. Yes, Shillong, Churachandpur. How was your break? Nice? So what were we discussing before the break? Tell me. Yes, Shillong. Settle down fast, please. So what was the topic of discussion before the break? Tell me. So I wanted to show one diagram to you people. Since you were getting late, I did not show at that time. Let's have a look at this. Okay, fine. Let's have this. Okay. Can you see this diagram? This is a diagram from your book only. Okay. Okay. Can you make out all the things? Can you see in the diagram all the things that are showing here? See, this is the oral cavity part. An oral cavity has two things. I taught you that. One was vestibule, second is mouth. Then the oral cavity opens into a common aperture, common space called pharynx. And then we have esophagus. We have done this thing. Stomach. From stomach, food goes into the duodenum. Then jejunum. Ileum. These all things are present over here. Then from ileum, the food goes into the first part, that is the vermiform appendix. Next, cecum. This is since going up. So this would be the ascending colon part. This is running transversely or parallel. So this is called as transverse colon. This is coming down, descending. This would be descending colon, and this thing over here, this is the sigmoid colon. Okay, this is the typical structure, and finally the sigmoid colon connects to the rectum, and finally the anus part. So this is the overall structure of the alimentary canal we were discussing before the break. Okay? Fine. Am I clear up till now? Any doubts? Tell me. Churachandpur, Shillong, do you have any doubts up till now? No doubts? Okay, fine. So this was the story, this was the thing which we are supposed to have when we are talking about alimentary canal. Okay. Let us do some questions for this chapter. Okay, so what is the movement of the gut wall known as? What is the movement of the gut wall known as? What is it? This is for number 4, isn't it? This is number 3. Okay, plus was also number 4. Okay, fine. Okay, so obviously, what do you think, Churachandpur? Yes. It's no doubt peristalsis. Peristalsis, we have just now studied peristalsis before the break, that it is the contraction and relaxation wave that your esophagus, that your alimentary canal actually has to push the food in a particular direction. Okay, the hardest constituent of tooth is, the hardest constituent of tooth is, and the hardest component of the tooth, Chuachandpur. Okay, very good. Here Chuachandpur seems very active now, like, is good. Yes, Shillong? The hardest constituent of the tooth. Very good. Very nice. Both the centers, keep it up. It's enamel. Okay, I have not taught you this. Okay. What about this? Is that an easy question? Yes, Chuachandpur. The fifth question. Yes, exactly. So, function unit of villi are the finger-like structures. We have studied this thing, isn't it? They are the finger-like structures. We have studied Peyer's patches. What Peyer's patches do? They produce lymphocytes. So, this is the correct option, villi. Okay, fine. So, enzyme trypsinogen. Oh, I'm sorry, we have not done this thing. Okay. Again, the question in a different form. The first question in a different form. Yes, Chuachandpur, Shillong. Okay. A very, very, very easy question. This is okay, fine. So this is a dentition you are having. We have studied this in the last class yesterday. This is the incisor. This is a canine, only 1/3. Two premolars, that is 4 and 5. One canine, 1 and 2 incisors, and then 6, 7, 8, what? Molars. So the dental formula was 2123 upon 2123 for adults. For you people or below 22 years of age, it was 2122 upon 2122. And for small children, it was 2102 upon 2102. This was for small children. Remember this dental formula? We have done this earlier also. Okay, this is GIF. You can see this GIF to see how the epiglottis actually works. You must have heard about a particular flap-like structure that prevents the food from entering in your trachea. This part is your trachea. This part happens to be the trachea part. So the food should not enter in the trachea. What happens is, when we are swallowing, this structure is called as epiglottis. So this epiglottis makes sure that the food is swallowed in such a way that it does not enter the trachea. See, this is the closure of the epiglottis and the food comfortably passes into the esophagus. No, that is the reason why we are not allowed to, why we are not asked to speak or laugh while eating. Because when we are doing such kind of activities, our trachea is actually involving. And because of the involvement of trachea, the epiglottis is not closing properly. Okay, fine. The movement of thing into the esophagus. So this is the esophagus part that I was discussing before the break. So esophagus, there is a sphincter over here, there is a sphincter over here also. This was the cardiac sphincter. Remember? This was the cardiac sphincter. The part of the stomach where esophagus opens is called as cardiac. The roof of the stomach is fundus. Now there is one more part called as body. And finally we have the fourth or the last part called as pyloric sphincter, which is guarded by last part called as pyloric part, guarded by pyloric sphincter. Now coming to the layers of the, these are the layers of the alimentary canal. Next heading, We shall start with a new topic, that is layers of alimentary canal. So the outermost layer is the serosa. Just inner to serosa, the second layer is muscularis. Third is submucosa, and fourth is mucosa. These are the typical structures, these are the typical layers of your alimentary canal. Let's see all of them one by one. Starting from mucosa, this happens to be the innermost, and it has connective tissue called as lamina propria, and this has muscularis. I need to change the pen type, it's very, very thin. And muscularis mucosa. This is the mucosa layer, the innermost layer. Now this layer is known to produce mucus, a huge amount of mucus is produced. Next comes the submucosa. Let us discuss about submucosa. This is actually having loose connective tissue. And the most important part about submucosa is a plexus called as Meissner's plexus. This often comes in exam. Plexus is a nerve ending. Okay, whenever you hear the term plexus, understand that this is a nerve ending which actually controls the secretion of intestinal juice. This controls the secretion of intestinal juice. Clear? Next layer is the muscularis layer. The muscularis layer, as the name suggests, this is actually having another plexus called as Auerbach plexus, A-U-E-R, Auerbach's plexus. What is Auerbach's plexus doing? This Auerbach plexus is actually responsible for controlling peristalsis. This controls peristalsis. This is Auerbach's plexus. It is also called as myenteric plexus. It's Auerbach plexus or myenteric plexus. Okay? So these are the four layers. Coming to last layer, that is serosa. I will be writing about serosa here. Just putting a star mark here and then connecting it. This serosa layer is actually the outermost, and this is formed of squamous epithelium. Remember squamous epithelium? We were discussing that in the buccal cavity also. It is made up of squamous epithelium and has areolar connective tissue. There are many different types of connective tissues, like you have studied adipose, you have studied areolar in chapter number 7 of class 11th book. So this is actually one of the types of connective tissue that serosa has. Now how many of you have heard this term mesentery earlier? How many of you have heard this term mesentery earlier? Yes, tell me. How many of you have heard this term mesentery? Are you able to see this? Tell me if you're not. This is mesentery. What is mesentery doing? Mesentery is actually the particular part which keeps intact all the body, all the members of your alimentary canal. So you can just imagine a situation that you are running, okay, or you're just running from here and there. So if this mesentery is not present, what is going to happen? The organs, they will start to move from their position. So this mesentery is having a function to hold the organs at that particular position, and this is especially present in intestine. Now, this is also, I would like to add, this mesentery is the 79th organ of your body, which was actually given a status of organ just like two years ago. 2 years ago in December, it was given a status of the organ. Earlier than that, this was only considered to be a part, not an organ in fact. And this mesentery is supposed to do a function. What? This holds the intestine. So this serosa is actually connected to mesentery. Why I have written this thing now? This is connected to mesentery. That is why we have mentioned this thing now. Okay, let's once again see all the things. We will start one by one. The first thing is the layers of the alimentary canal. The first layer was serosa, the second is muscularis, the third is submucosa, and the innermost or the fourth is mucosa. Next thing, important things about serosa, the first layer, important things about mucosa. Mucosa is the innermost layer and it has connective tissue called lamina propria, and it has also muscularis mucosa. Excuse me. The function of the mucosa is to produce mucus. We will come to know later why is it known to produce mucus. Then the submucosa layer, important thing about submucosa is it has a mesenous plexus, and the mesenous plexus, this does comes in exam. This is responsible for secretion of intestinal juice. Comes the muscularis layer. Muscularis layer has plexus of Auerbach, Auerbach, and this is also called as myenteric plexus. What is it doing? It is controlling the movement of your alimentary canal called as peristalsis. Followed by this, we have the outermost layer. This outermost layer is actually connected to the mesentery. And what is mesentery? Now we know what is mesentery. It is a particular part, or it is a 79th organ. You can just mention in bracket over here that this is the 79th organ that you have actually discovered 2 years ago. This is the 79th organ we know. Now we have 80 organs in our system. The 80th organ discovered, does anybody have an idea? Have any idea? Have you heard about the 80th organ? Tell me. Have you heard about the 80th organ? Have you heard about interstitium? Tell me. Have you heard about interstitium? The space present between the organs is called as interstitium. 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 I'm rewriting here. Interstitium. Now this interstitium happens to be the 80th organ of your body. So 79th is mesentery and 80th is interstitium. Okay. Any doubt up to this? Tell me. Yes, Shillong, Chuachandpur, tell me if the things are clear. Just give me a thumbs up, Shillong. Chuachandpur, please type if it's clear. Do I need to repeat anything? Okay, got your answer, Shillong. Very good. I did not repeat anything. Shall I repeat anything? Things are clear. Did you copy nicely? Okay, fine. Very good. Very nice, Chuachandpur. Very good. So this makes the diagrammatic representation of your alimentary canal very, very clear. Let us start the next topic we are supposed to start. We are supposed to start with the next thing that was, remember yesterday we divided our digestive system into two parts. The first was alimentary canal. So let us start with the second part of the digestive system, that is the associated glands. So yesterday also I gave you a list of glands, and obviously I am starting from the buccal cavity. So the first gland, I will be discussing only salivary glands today. So the first gland today we are going to discuss from your buccal cavity is your salivary gland. So where is salivary gland going to pour its secretion? This is going to pour secretions in the buccal cavity. Okay, now what kind of gland is it? Is it an exocrine gland or endocrine gland? What is it? Exocrine or endocrine? Tell me. Chuachandpur, Shillong. Is it an exocrine gland or endocrine gland? Tell me, exocrine or endocrine? What is it? This is for exo, this is for endo. Thumbs up for exo, thumbs down for endo. Chuachandpur, you please type your answer, exocrine or endocrine? I'm not able to see you people. Yes, Chuachandpur, is it exocrine or endocrine in function? Tell me, I'm waiting. Yes, Shillong, what do you think? Exocrine or endocrine? Definitely, salivary gland is an exocrine gland. Now, there are two kinds of glands. It is exocrine and endocrine gland. Exocrine are the glands which need ducts to pour their secretions, to pass their secretions. So, if ducts are present, we call them to be exocrine. If ducts are not present, absent, it is called as endocrine gland. Very good, Chuachandpur. Very nice, Shillong. So let us discuss how much saliva the salivary gland produces. All of us know the salivary glands are producing saliva. How much saliva per day? Any idea? Yes, Shillong? Tell me how much saliva per day is it producing? How much saliva per day is your salivary gland producing? Tell me. Yes. One of you please get up and type if you have any idea. Chuachandpur, let me know how much saliva is your salivary gland producing. All your salivary glands are producing per day. Yes. Are you Googling? Are you trying to search on Google? Yes, Shillong? No, you cannot. Okay, tell me, any idea? It's 1.5 liters in a single day. How much saliva? 1.5 liters in a single day. And what is the pH of saliva? If a question comes to you, this is 6.8 pH. Keep on copying. These things are very, very important. Questions do come from these topics. Let's see what is the composition of saliva. What is saliva made up of? Okay, did you copy the slide? Shall I proceed? The composition of saliva. Obviously, the saliva has a huge amount of water, we all know. It has a particular product called as mucin, which gives it a binding capacity to food. The food what you chew is actually bound in a bound form. If you have ever noticed, it becomes bound in a form, and that binding is basically because of this mucin thing. And followed by mucin, what we have is, we have an enzyme called as salivary amylase. The old nomenclature, old name of salivary amylase, many times asked in exam I have seen, is ptyaline. Ptyaline is its old name. Salivary amylase is its new name. Then we have is lysozyme. lysozyme, sorry. It is lysozyme. This is actually antibacterial in nature. You must have studied biotechnology where you were supposed to isolate a cell, and to isolate that cell, we were supposed to use, if the bacteria genetic composition was used, we were using lysozyme for the activation. Now we have NaCl. The importance of NaCl can be understood that Cl minus is required for activation of salivary amylase. Required for activation of salivary amylase. So this is the best thing we can know about the saliva. Okay, both the things, Na as well as Cl, not only Cl but it's both the things, Na plus and Cl minus are required for the activation of saliva. Now let's come to the salivary glands. So we have 3 glands. Did you copy this? All of you? Chuachandpur, Shillong, have you copied this slide? Can I move ahead? I'm moving, just let me know in case you did not. So we have 3 salivary glands. The first is the parotid. The second is the submandibular. And I'm rewriting this can be confusing to you. Submandibular, and we have a sublingual. The parotid gland is present in front of the ears. In front of ears. Submandibular, this is actually present below the jaw. And lingual means tongue. So this is present below the tongue. Okay, so these are the typical locations. This is the largest gland, largest of all. Sublingual happens to be the smallest of all. I'm moving ahead. What we have is, this is actually releasing, since you know we have these particular glands which are exocrine in function, so they must be having certain ducts. This the particular duct which releases the secretions in the mouth is called as Stinson's duct. So a Stinson's duct, what they do is that they connect the parotid gland to the buccal cavity. Similarly, the submandibular has different kind of duct called as Wharton's duct. So this Wharton's duct, it helps to secrete secretions directly into the buccal cavity, and we have a sublingual part has Rivinus duct. Again doing the same thing. So we have over here a set of 3 ducts respectively present in parotid, submandibular, sublingual, called as Stinson's duct, Wharton's duct and Rivinus duct. Let's see the secretions, what they are contributing. 25% of the saliva is coming from your parotid gland. Okay. Then you have from this particular part actually 70% of saliva, and sublingual contributes only 5% of saliva. So it's not the largest always contributing the highest. Just make sure the largest is only contributing 25%, but the middle-sized one is contributing the 70%, whereas the smallest is only contributing 5% of the total saliva. Okay, let us have things up till here. We'll be resuming this topic again in the next class. In the meantime, let me know if you have any problem. We'll resume this topic in the next class. Let me know if you have any problem. First, let me know if you have any problem, yes or no. Before wrapping up your things, going home, Shillong, Churachandpur, let me know if you have any problem. Or everything is clear? Everything is clear? Yes, Shillong? Tell me, Churachandpur. I know you people are in a hurry, but let me know if the things are clear. Yes, please. And you have many questions left. Let us see how many questions are left in the assignment I gave you in the last class, yesterday. So we have done only 10 questions from that part, and we have this thing, isn't it? This was the thing we discussed, 10 from this thing and 10 for this thing, and you have like 10, almost 20 questions are almost left to be done. So what you will be doing is that in the next class, whenever we meet, you are going to get all these questions solved, and from that day onwards, what we will be doing is that we will be starting the assignment for digestion. Okay, am I clear? Packed your bags? Okay, fine. Packed your bags, everybody? Okay, then thank you so much. We will be meeting in the next class. In the meantime, if you have any doubt, you can just connect to me on the WhatsApp group we have. Okay? Just go back home and study hard. Okay. Thank you so much, Churachandpur, Shillong. Bye.